basic shapes, rectangle, circle, triangle. A parallelogram is the same thing as a rectangle as far as area goes. It's just a tilted over rectangle, so it's still just length times width or base times height, same thing. So an area of a rectangle is base times height. You need to recognize that a lowercase b means the base, but a capital B means the area of the base. Okay, so when we do volumes, you have to do the area of the base times the height for certain figures, and that's why these have a capital B. Okay, a lowercase b means the base is a 2D shape. Okay. Area of a circle is pi r squared. Area of a triangle, 1/2 base times height, because the area of a triangle is just basically half that of a rectangle. Volume. Now, an easy way to remember volume, if you have parallel bases, meaning, okay, I say the top and the bottom are the same shape. The bases are the same shape. It doesn't come to a point. It's the top and bottom are the same shape, okay? For example, rectangular prisms, triangular prisms. The only difference is that the base is a rectangle for a rectangular prism and a base is a triangle for a triangular prism. Triangular prism. And cylinders. So all of these have the same base on top and bottom. This has a rectangle or a square on top and bottom. This has a triangle on top and bottom, even though it's tilted like on its side. And this has circle for top and bottom, right? The top and bottoms are the same. You could flip it over and it would look just the same. Okay? Those are all the area of the base times the height. So whatever the base is, if the base is a circle, it's pi r squared times the height. If the base is a triangle, it's 1/2 base times height times the height of the prism. If the base is a rectangle, it's length times width times the height of the prism. Okay? So area of the base times the height. Everybody with me? The other type of shape is if you don't have the same on top and bottom. If it comes to a point. But you can still have all three different types of bases. Okay? If it comes to a point, if it has a pointy top, then the volume is 1/3 times the area of the base times the height. And that's because if you go on YouTube or if you go on Google, when you type in why is the area of a pyramid 1/3 base times the height, it'll show you that if you volume is like how much liquid could you fill it, right? If I filled this little figure with liquid 3 times, it would fit into a triangular prism. That volume, this is literally 1/3 of that. You could put 3 of these in a regular triangular prism. Or cones. You could fit 3 cones into a cylinder. Okay? So if you took a cone and filled it up 3 times, it would fill up a cylinder, a whole cylinder. Okay? So if it comes to a pointy top, it's 1/3 times the area of the base times the height. So if the base is a rectangle or a square, it's 1/3 length times width times height. Now your height has to be from the center of the base to the top. Okay? So this is your height. And it forms a right triangle with that face. Do y'all see that? This is called the slant height. There's the height of the 3D object, and then there's the slant height. The slant height is going up the side of it. It's not directly up and down, it's like this. And so if they give you the slant height instead of the actual height, you have to use Pythagorean theorem to find the height. Okay, does that make sense? So slant height, that's what that's called. Okay, same thing for cones. If they give you this and they don't give you the height, you have to use, that's a right triangle, you have to use Pythagorean theorem to find the height before you can plug it into your volume formula. You can't use the slant height in the volume formula. You have to use the actual height. Okay? Remember I said if we measure a distance from something to something, it has to be the perpendicular distance. So if we want to know the distance from the top of this cone to the bottom, it has to be perpendicular to the bottom. Any questions? So if the top and bottom, if the bases are the same on top and bottom, it's just area of the base times the height. If it comes to a pointy top, then it's 1/3 the area of the base times the height. The only last one that we have as far as volume goes is a sphere. And I don't have a logical explanation of why this is the volume of the sphere. I tried to look it up and it was too complicated. The volume of a sphere is 4/3 pi r cubed. Okay, so that's just one you're just going to have to memorize. I don't have any logic for that. It's 4/3 times pi r cubed. I tried to look it up and it was above my paper. Okay, so 4/3 pi r cubed. So in all of these, if they give you the diameter, you need to have the radius. If it's a circle, okay, things like that. If they want you to find the volume of a compound figure, that means more than one. They want you to find the volume of a compound figure. Then you have to add up the volume of each individual piece. You guys remember doing that? Okay, so this right here, if they want you to see how much liquid can fit in this wine glass, well, that's not a shape that I know, correct? But if we know from here to here 6, halfway is 3, right? This piece right here is half of a what? Half of a sphere. And then this right here, the top part, is a cylinder. So you do the volume of the cylinder plus the volume of half of this sphere. Okay, because if I completed it all the way around, that would be a whole sphere. Correct? So this is from here to here is 6, so the radius of this sphere would be 3. Okay? And the radius of the cylinder would be 3. Okay? Any questions? If we needed to find the volume of this piece right here, that's not a shape that we just know the volume for. But I can break that up into 2 separate pieces. This piece on the left plus this piece on the right. So you have to figure out what the dimensions of each of those pieces are based on what they gave you. Okay? Yes.
For that one, maybe also like...
Yep. You could do it. Yes, you could. There are several different ways to approach this. That's exactly right. You could do the volume of the whole piece, assuming that piece was not taken out, and then subtract out this block right here. That's fine too. Or you could break it up like this. Okay, and do the front piece and the back piece. That's up to you. Okay. Surface area. Surface area. Surface area sounds simple. It's like, okay, surface area, you just add up the area of all the sides, all the faces. Okay. You have to be careful with surface area. Because if I'm finding the surface area of this, okay, so it's a cylinder on top of a cylinder, correct? Surface area of a cylinder is this formula. And let's look at a regular cylinder. So surface area is if I had to paint the outside of that. Okay? Well, we know we have a circle on top and bottom, right? So it's the area of the top plus the area of the bottom. Okay, so circles, what's the area of a circle? Pi r squared, right? So it's 2 times pi r squared. That'll cover the top and bottom, right? Now, the outside part, so we have a cylinder like this, right? Looks like this, correct? So I cut it and open it up. It's a rectangle now, right? Right? So if I cut this and opened it, it's a rectangle. Rectangle, what's the area of a rectangle?
Base times height.
Right, base times height or length times width, correct? But you have to assign values. This was a cylinder that looked like this. What is this top right here? The circumference of that circle, right? What's circumference? 2 pi r. So the length or the width is the circumference. It's 2 pi r, correct? and this is the height, right? So if I wanted to find the area of this rectangle, this is 2 pi r, and that's the height. Does that make sense? Because the length or the width is the circumference of one of those circles. So it's 2 pi r, so the area of this, the outside part, is 2 pi r h. So that's where they get that formula from. That's where they get this surface area formula from, 2 pi r h plus 2 pi r squared. Because this covers the circles on top and bottom, and this covers the outside face of the bulk of the cylinder. Does that make sense? Okay. So the surface area of the cylinder. Now, surface area of a sphere, again, spheres, I don't know the logic behind the surface area of a sphere, you just have to memorize it. It's 4 pi r squared, okay? So if you have a sphere and you need to know how much it's going to take to paint it, how many square inches that sphere is, then it's 4 pi r squared, okay? Now, also be careful when you're doing surface area, because if I'm going to find the surface area of this figure right here, it's the surface area of the top cylinder minus the surface area of the bottom cylinder, right? I mean, plus the surface area of the bottom cylinder. However, I have to subtract something. If I'm going to paint this figure right here, what's not going to be exposed? Yes. The bottom of the cylinder on top. That's on top of the other one, so it's not exposed. So you don't include that in the surface area. Okay? So you have to do the surface area of the cylinder on top plus the surface area of the cylinder on bottom minus the area of one of these tiny circles. Okay? Huh? No, this one.
So it's also covering a piece of the area.
It's the same heat.
Yeah, but not.
This is what I was calling slant height. It's that the side on the face, when they give you the height on the face of the pyramid, you actually need the height of the entire pyramid. So if this is 12, what's this base? 6, because it's the radius. Or not radius, but it's half of that. And so you would have to use Pythagorean theorem to find the height of this. So you do h squared plus 6 squared equals 10 squared. Let's see this. Let's see if we can answer these questions. Which 3D figure? Oh, you have the answers. Which 3D figure would be best for modeling a human torso? This torso.
Cylinder.
Cylinder. What about a tree trunk? Cylinder. A slice of cake. Okay, so once again, I guess it depends on how you're cutting the cake. You're not cutting it. It could either be but regardless, it's going to be a prism. But it could either be a rectangular prism or a triangular prism. Unless you're super, or a cylinder. But regardless, right, but the top and bottom are going to be the same shape, right? I don't know who cuts a cake in a home, but still.
I was right.
Ice cream cake.
A house. Now that's a combination. A rectangular prism
And a pyramid.
Yeah, I guess it depends on the design of your house. But I like the way you all think.
Have you seen the Barrel House? Which is it's a complete circle. No, I swear there's
Okay, we can all agree. Now, how would you approach this? It says, how would you calculate the volume of the empty space, which is probably what they'll ask you on your final exam. It'll say, what is the volume of the empty space inside a 12-pack of sodas? Now, they'll give you things like the diameter of the cans, how tall the cans are. They'll give you things like that. Yes?
So do you need to find the area of the rectangular prison boxes and subtract the area? Volume.
Yeah, I knew what you meant. So you take the volume of the whole box, the cardboard box, which is a rectangular prism, volume of that, and you subtract out the volume of the can. So you'd have to multiply those by 12, the cylinders, and then subtract that out. What would be left would be the empty space. Yes? Density is mass divided by volume. Density is mass divided by volume. Volume, you always know which, if they give you the volume, it'll say cubic inches or cubic feet or cubic whatever. So you'll know that that's the value for the volume. It's because the unit is cubed. Okay? Mass will be in grams or kilograms or something like that. Okay? Density, if they give you the density, it'll give you the grams per whatever, or the kilograms per cubic inch, or so density will be measured like that. Okay, so for example, if the mass of an object is 5 grams and the volume is 10 milliliters, how much is the density in grams per milliliter? Okay, so they want to know. We know that density equals mass over volume. They're asking for the density. They tell us the mass is 5 and the volume is 10, so that's 0.5 grams per milliliter. Okay? All right? Now, this one's a little bit different. A hot air balloon holds 74,000 cubic meters. So what does that represent? Nope. Volume. Cubic meters. That indicates volume. Okay? With a density of 0.1785 grams per cubic meter. So the density is 0.1785. How many kilograms of helium does the balloon contain? So they're asking you to find the mass. So if they want to know the kilograms, that's mass. Okay? So density equals mass over volume. Now, you also have to pay attention to your units here. So if they tell you that this was kilograms per cubic meter and they want to know how many grams, you're going to have to convert your answer. Okay? So the density is 0.1785. We don't know the mass, and the volume is 74,000. So what do? You just multiply those two together, and you get the mass is 13209 kilograms. Now they asked you in kilograms, and your units were already kilograms, so you're good. Now, what if so I'm going to tell you this conversion. 1 gram equals 1,000 milligrams. 1,000 grams equals 1 kilogram. Okay? So if I wanted you to change these kilograms to grams, let's remember how to do that. Remember when we did degrees to radians and radians to degrees and we went over this conversion stuff? Yes, you do. Of course you do. So if I wanted to change 13209 kilograms, if I wanted to change that to grams, I have to multiply times something over something. I have to multiply it times what the conversion is. Am I going to do kilograms over grams or grams over kilograms?
Grams over kilograms.
It's what you want on top. Grams over kilograms. So my conversion is this. So 1,000 grams over 1 kilogram. And you see what happens is my kilogram units cancel, leaving me with just grams. Okay? So all you'd have to do is multiply those. All right? So that would equal 13,209,000 grams. Okay?